Okay, we finally reached the end of this chapter. Good times. So, what I'm doing here, I'm going to go through some exam questions on various content from this chapter or playlist. In particular, I've had a request from Osman. Hello, my friend. You asked me for more problem-solving type questions when it comes to the factor theorem and remainder theorem. So, I'm making sure I put some of those in here. Okay then, let's get cracking. Okay, question 1. So, the polynomial p of x is given by p of x is x cubed plus bx squared plus cx plus 24, where b and c are integers. So, that's important. Whole numbers. Given that x plus 2 is a factor of p of x, show that 2b minus c plus 8 is equal to 0. Okay, so we're problem solving straight away. Let's think about what we know then. So we are given x plus 2 is a factor. So if we use the factor theorem, then we know that if x plus 2 is a factor, then p of minus 2 will be equal to 0. So we set x equals to minus 2 in the expression. So we're going to get minus 2 cubed, which is minus 8, times b lots of minus 2 squared. Minus 2 squared is 4, so we got plus 4b, and then c lots of minus 2 is minus 2c, and then we got plus 24 at the end. Now we know that that has to equal 0. So minus 8 plus 24 is 16, so we've got 4b minus 2c plus 16 is equal to 0, and then if we divide by 2, we get 2b minus c plus 8 is equal to 0, as they wanted us to show. Good times. Okay, part B then tells us the remainder when p of x is divided by x minus 3 is minus 30. We want to use that information to obtain a further equation in terms of b and c. So, let's change colour. So, by the remainder theorem now, so for part B, if when the expression is divided by x minus 3, the remainder is minus 30, this tells us then p of positive 3 is equal to minus 30. So we now substitute 3 in. So we get 3 cubed, which is 27. Plus b times 3 squared, so that's going to give us 9b, plus 3c, plus 24. Now we know that that is equal to minus 30. Good times. So, if we sharp up the left hand side a bit, 27 add 24 is a number 51. So we've got 9b plus 3c plus 51 is equal to minus 30. If we take the 51 away, we get 9b plus 3c is minus 81. And we've now got a common factor of 3. Let's divide that away. We get 3b plus c is equal to minus 27. So there's our second equation in terms of b and c. Okay, now part C wants us to use the equations that we found in part A and B to work out the values of B and C. So it's now a game of simultaneous equations. So there are our two equations. Let's call them equation 1 and equation 2. It's the cool thing to do. Okay, now what can we notice about both equations? Well, equation 1 has a minus 1c, equation 2 has a positive 1c. So we can add the equations together and c will disappear. Yay. So that's exactly what we're going to do. We're going to do equation 1 add equation 2. So 2b add 3b is 5b. Minus c add c cancels out, that's the whole point. Now we've got an 8 still on the left hand side. And then on the right we've got a 0 add minus 27, which is minus 27. If we then take away that 8, we get 5b is minus 35. Okay, times, dividing by 5 tells us then b is equal to minus 7. Okay, times, now we know that b is minus 7, substituting that into one of the equations, I'm going to go for equation 2. So if b is minus 7, 3 times b is minus 21. Add c, and that is equal to minus 27. And then finally, if we add the 21, c is minus 6. There are our values of b and c. Good times. Okay, more polynomial fun for the second example. This time, p of x is equal to x cubed minus 5x squared minus 8x plus 48. Part A asks us to use the factor theorem to show that x plus 3 is a factor of p of x. So, for part A, if x plus 3 is a factor, then p of minus 3 will equal 0. So we're substituting in then x equals minus 3. So p of minus 3, well, it's going to be minus 3 cubed, which is minus 27, minus 5 lots of minus 3 squared, which is positive 9, so we got minus 5 times 9, then we got minus 8 lots of minus 3, so minus 8 times minus 3, and then plus 48 on the end. Now, so we got minus 27, minus 5 times 9 is minus 45, Now we got minus 8 times minus 3. That's positive 24. So add 24 and then add 48. Does that equal 0? Well, we hope so. So minus 27 minus 45 is minus 72. And then 24 add 48 is 72. So we got minus 72 add 72, which does indeed equal 0. Therefore, x plus 3 is a factor. Good times. Okay, and then part 2 of question A asks us to write p of x as the product of 3 linear factors. So I'm just going to use the factor theorem to do this. So for part 2, well, we now know p of x has one factor of x plus 3. We know that it has 3 linear factors because they are asking us to write it in terms of those. So we know that we can write it as x plus a times x plus b. So we just need to find the values of a and b. Okay, now then, before we go gung-ho with the factor theorem and we try every single number that there is, before we get to our answer, let's be a little bit clever. So we know if we multiply the numbers in the brackets together, we can get the number at the end of the polynomial, which here is 48. So we know 3 times a times b is equal to 48. So we know if we divide by 3, a times b is equal to 16. So whatever a and b are, they need to multiply together to give us 16. So we only need to try factors of 16. Now, this is the second cut of me doing this. I know that 1 and minus 1 don't work, so I'm not going to try those again. So let's try 2. So p of 2, it would give us 2 cubed, which is 8, minus 5 lots of 2 squared. 2 squared is 4, 5 times that is 20, so we get minus 20, minus 8 lots of 2, so minus 16, and then plus 48 at the end. Now it's quite easy to see that's not equal to 0. So that's no good to us. Let's try p of minus 2. So that's going to give us minus 2 cubed, which is minus 8. And then minus 5 lots of minus 2 squared. So again, that's going to give us minus 20. And then we've got minus 8 lots of minus 2, which is positive 16. And then positive 48 at the end. Now minus 8 minus 20 is minus 28, but then we got plus 16 plus 48. So that is definitely not equal to 0. Bugger. Next, let's try 4. So p of 4. Well, that's going to be 4 cubed, which is 64. minus 5 lots of 4 squared. Now 4 squared is 16, 5 times 16 is 80, so we got 64 minus 80, and then we've got minus 8 times 4, which is minus 32, and then plus 48 on the end. Now 64 plus 48 is 112, minus 80 minus 32 is minus 112, which does indeed equal 0. Good times. Therefore, x minus 4 is a factor. So, we can now write p of x equals x plus 3 times x minus 4 times, well, we can actually now write down the final factor too. Remember that we worked out a times b had to be 16. If a is minus 4, then b has to be minus 4 too. Like that. So 3 times minus 4 times minus 4 does give us that positive 48 that we need at the end. So we've done part 2. Okay, part B asks us to use the remainder theorem to find the remainder when p of x is divided by x minus 2. So to do that, we substitute in x equals positive 2. So p of 2 is going to be 2 cubed, which is 8, minus 5 lots of 2 squared. 2 squared is 4, so we got minus 20, minus 8 times 2, so minus 16, plus 48. So what do we get here? Well, and again, I like to group together my same sort of sign. So, 8, what do I mean by that? I would do 8 plus 48 first, which is 56, and then minus 20 minus 16 is minus 36. So, we get 20 there, like that. Good time. Okay, then for part 2 of question B, I'm going to do this 2 different ways. So, we want to express p of x in the form x minus 2 times x squared plus bx plus c plus a remainder. Now, from part A, we already know the remainder. The remainder is 20. So, r is 20. So, the first way that I'm going to do this, I'm going to use algebraic division. In the second way, we're going to compare coefficients. So, part 2 then. So, we want to express the polynomial as the product of x minus 2 times a quadratic and a remainder. Now, if we... let's write out the polynomial first of all. So, it's x cubed minus 5x squared minus 8x plus 48. Now we want to write this as x minus 2 times the quadratic, so x squared plus bx plus c plus the remainder. Now, if we're thinking about this in terms of algebraic division, we would divide through by x minus 2. So, if we did that, we would have x cubed minus 5x squared minus 8x plus 48 over x minus 2. Now that is going to give us the quadratic. So x squared plus bx plus c plus the remainder over x minus 2. So if we now do the division, we can find the quadratic. We know the remainder is 20 already, but let's show it. So, algebraic division. Good times. Okay, so set it up as a long division. So, x cubed minus 5x squared minus 8x plus 48 divided by x minus 2. Okay. So, I've just done 3 videos on this. Hopefully you're quite confident with this by now. We divide the first term under the sign by the highest powered x term in the divisor. So, x cubed divided by x is x squared. Now that goes up on top of the division sign like that. Then we multiply that by the divisor. So, x squared times x minus 2 gives us x cubed minus 2x squared. Now we write that underneath the cubic. So, x cubed minus 2x squared. And we now subtract the blue expression from the red. So x cubed minus x cubed cancels out. Minus 5x squared minus 2x squared is going to give us minus 3x squared. And then the 2 other red terms fall down. So we got minus 8x plus 48. Like that. So we now repeat this cycle with this blue quadratic now. So 3x squared divided by x is 3x. That's, it's minus 3x squared. So minus 3x squared divided by x is minus 3x, like that. So minus 3x is the next thing that goes up on top, like that. And then we multiply that by our divisor. So minus 3x times x minus 2 gives us minus 3x squared plus 6x. So we now write that underneath the blue. So we got minus 3x squared plus 6x. Like that. So we now subtract the purple from the blue. So minus 3x squared minus 3x squared cancels out. Minus 8x minus 6x gives us minus 14x. And then the 48 falls down, so we got plus 48 at the end. Now we repeat that process one more time. So we now do minus 14x divided by x which is minus 14. So that is the final term in the quadratic that we are looking for. Good times. So now we just need to go through and find the remainder. So, minus 14 times the divisor x minus 2 gives us minus 14x plus 28, like that. So we now write this underneath the purple, minus 14x plus 28. And then if we do the subtraction, minus 14x minus 14x cancels out. 48 minus 28 again gives us our remainder of 20. Good times. So, what we've now worked out then is x cubed minus 5x squared minus 8x plus 48 divided by x minus 2 is equal to x squared what was it? X squared minus 3x minus 14 minus 14 like that. So there's the quadratic. And then the remainder was 20 over x minus 2. If we then multiply through by x minus 2, we get p of x is equal to x minus 2 lots of x squared minus 3x minus 14 plus our remainder of 20. Plus our remainder of 20. Okay, so that's how we can do that using algebraic division. It was fun. Now I'm going to do it a different way. Okay, so the alternate method, and in all honesty, this is probably the easier of the two. But it's good to cover our bases, practice our techniques, take our time. Right, so in part 1 we have worked out the remainder when p of x is divided by x minus 2. We worked out the remainder is 20. So we already know r. So we can already write p of x is x minus 2 times x squared plus bx plus c plus the remainder of 20 plus the remainder of 20 on the end, like that. So using this method, what we're going to do, we're going to compare or equate coefficients. So the first one that's easy to find is c. Now, up in p of x we know the constant term, so the number at the end with no x attached, is 48. If we were to expand all of this, the constant would come from doing minus 2 times c and then plus 20. So we know minus 2c plus 20 has to give us the same constant as we have at the top, which is 48. So if we take away the 20, minus 2c is 28. Divide by minus 2, c is minus 14. as we just worked out by algebraic division. But as it turns out, this was a lot quicker. Okay, now we need to work out what b is going to be. So let's think about the x squared coefficient that we would get if we multiply this all out. So we would get x times bx first of all. Now that would give us bx squared. And then we're also going to get an x squared term when we do minus 2 times x squared. So that's going to give us minus 2x squared. Now that we can write as b minus 2x squared. Now in p of x, the x squared term is minus 5x squared. Okay, so we know the x squared term on the left has to be identical to the one on the right. In other words then, b minus 2 is minus 5, therefore b is minus 3. So, there we go. We've worked out our values of b and c a different way, got the exact same answers we had to. So there's 2 different ways of doing the same thing. Okay guys, calling it a day for this video. It's turned out to be a lot longer than I planned, as always. So if you want more of these, just let me know down below in the comments section. Take it easy guys, it's Friday on the day I'm filming this. If you're watching this today, have a good weekend.